Slide 1. For successful completion of a project in a collaborative environment, where team members from different disciplines produce their own relative information, it's essential to define at the early stage of a project what information is needed from whom, at what stages, and to what level of detail. LOD has a range of terminologies, depending on the location. In the UK, LOD stands for Level of Definition and is split into two elements. LOD, which is Level of Model Detail, and LOI, which is Level of Model Information. In the US, it's described as Level of Development and has similar but slightly different objectives. In this instance, we'll be focusing on the UK version of its implementation. To give some background, LOD was introduced within BIM Protocol, released by AEC UK in 2009, as Level of Detail within its model development methodology. In 2013 PAS specification, for information management for the delivery phase of construction projects using BIM, now replaced by British standards EN ISO 19650, introduced Level of Definition as a new classification system with 7 levels to include both aspects of Level of Model Detail, LOD, and Level of Model Information, LOI. So looking a bit more at the differences, Levels of Model Detail, LOD, describes the graphical content of models. This can be determined as a placeholder, generic and detailed categories of LOD, for example. Levels of Model Information, LOI, describes the non-graphical content of models. This can be properties of an object, for example dimensions, material specification, insulation, or the cost of the building element. So why is this important? As the project progresses through stages 1 to 7, the level of detail and model information naturally increases. The classifications of LOD are designed to harmonise with the RIBA plan of work and give a structured approach to the BIM process, determining what level of detail needs to be presented at what stage. This is important as different teams exchange information. Implementing an LOD workflow ensures each team knows the aims for each specific stage, meaning the project can run much more efficiently.
Slide 2, Implementation. LOD is a specification methodology that allows the articulation, documentation, and specified contents of BIM in a clear and effective manner. Using LOD, architectural designers, engineers, and other applicable parties can effectively communicate using a BIM model to understand its usability and limitations. Both LOD and LOI are implemented through BIM software such as Revit or ArchiCAD. LOI is typically implemented within a project through manufacturer-specific data. As previously mentioned in slide 1, LOD was initially introduced in the United States in 2008. The first instance of LOD use was the development of a construction analysis software tool developed by Vico Software, which made use of LOD to associate digital models with the cost of a project. This initial concept has been adapted and influenced through varying factors over the years to develop LOD into what we understand today. Today, there is a varying range of software platforms that facilitate the use of LOD. Through the United Kingdom, the implementation of Autodesk Revit has become widespread due to excellent adaptability and collaborative modelling through LOD. In the United Kingdom, LOD is defined through LOD 1 to 7. This differs from its American counterpart in the aspect of having 2 more stages, being Stage 1 brief and Stage 7 in use. Stages 2 to 6 can be compared to its American counterpart in which each design stage is defined. LOD 100 is designed for the pre-design stage. LOD 200, the elements are partially defined by outlining their approximate quantities, size, shape and location. LOD 300, the elements are defined with exact dimensions, followed by LOD 350, which outlines the elements precisely in their relation and connection with other components. LOD 400 outlines the basic information with regards to the construction of elements. Finally, LOD 500 is defined as the operational model, bringing together the representation of real-world functions of the elements. An example of planning through LOD can be found in the tool LOD Planner, which facilitates the development of a BIM execution plan, otherwise known as a BEP. Another example of this could be Dynamo, which allows the interface of creating visual logic to explore parametric designs and automated tasking. LOI, level of information, differs slightly different to LOD. LOI is the information content of a BIM asset, so LOI typically refers to the properties of an object, for example, that of a furnishing model obtained from a manufacturer or a material specification element. This is a typical method of implementing LOI within Revit or ArchiCAD. One typical example of this is COBIE. This is a construction operation building information standard relating to the management of BIM assets. COBIE is a data schema that allows the definition of data required to populate a digital asset or facilitate a management system. An example of this implementation is that of a furniture population within a project, allowing the management of each BIM asset to easily be controlled. COBIE doesn't increase the requirement for information, it simply structures it into a more accessible format, allowing ease of use for management and design. If implementing, for example, an installation typology within Revit, changing the COBIE of said asset will allow the change of varying elements such as scheduling and cost. When taking into account any issues with the implementation of LOI and LOD, there are several factors that limit the implementation of both. This ranges from a lack of knowledge and trust of this type of workflow between subcontractors and designers, to difficulty implementing a suitable work infrastructure to facilitate BIM within a workplace. Speaking from experience, implementing this workflow methodology within a practice is limited by the computational infrastructure of said practice. Ensuring the identification of areas that require change and re-coordination within all trades is a vital requirement to ensuring that the adaptation of BIM, LOD and LOI can become the standard for the construction industry within the United Kingdom. The training of key management members in the understanding of BIM is vital, whilst ensuring subcontractors utilise BIM to review both the LOD and LOI of a model on site, which will allow a more thorough and effective project workflow.
So on the topic of LOD versus LOI, I'll be providing case studies to further support how this is used in the real working world. So there was a number of case studies which presented companies who worked on part of the project stages. I weren't able to find a company who had developed it from an early stage of LOD 100 completely to 500. However, I did come across a company called Rinsoft, I believe that's how it's pronounced. They worked on a beautiful Acorn City, a high-rise community within Dubai, being heavily involved with LOD stages 300 and 400. So to put this into context, this would be equivalent to RIBA stage 4 and the installation phase. Upon further research, I found how aspects of the case study could be implemented within our studio projects, particularly for stage 4, as we start presenting information such as modeled elements, accurate cost estimation, and regulatory compliance. And making sure they are regulatory compliance and specific with the building that we will be constructing. So some positives consist of distributing the load of the work, as different professionals will be focused on different stages. It provides an easy understanding of LOD 300 and 400, also greater level of detail being provided, allowing the project to be visualized in more depth. Negatives consisted of organizations. Issues may occur and the client themselves would have to deal with hiring multiple employers to complete the task.
Hello everybody, my name is Craig Gregory and I'll be taking you through slide 4 of the group presentation, which is legislation, resources and documentation available for both LOD and LOI implementation within building information modelling. So first and foremost, legislation. the UK government created a document called the Government Construction Strategy 2016, which was to set up a mandate to ensure all architectural, engineering and construction companies are to produce drawings at a minimum of BIM Level 2 by 2016, with further implementation as the years progressed. However, prior to this, there was no formal UK variant, and much of BIM was created upon the standards as set out by the USA. This created some confusion and controversy over both the terminology and the level of detailed information that was required when it came to the UK construction industry. As the USA defines LOD as level of development, the UK defines LOD as level of definition. Now, UK level of definition is aligned to the Digital Plan of Works created by the UK BIM Task Force, which provides the UK construction industry with an eight-stage design, construction and operation plan that encompasses the information requirements throughout the whole life of an asset, whereas the US system defines the stages of an increased model development as more detailed graphical representations using the terms LOD 100s through to LOD 500. So once this line had been created, the publication of PAS 1192-2 2013 was implemented, and UK BIM documents now use this rather than the US terminology and documentations which were used previously. So guidance and documentations that are now being used are, as mentioned, the PAS 1192-2 from 2013, which is then in line with the Digital Plan of Works and the RIBA Plan of Works, which all come under the UK BIM Task Group umbrella. These allow the life cycle of a project to be established and the creation of a 7-stage development process, including the additional benefits of employees' information requirements, BIM execution plans and master information delivery plans, to allow a collaborative and technically informative detailed electronical drawing package that would be in line with each progressive stage of the RIBA Plan of Development. Moving on to building, so UK building standards. There are 2 building standards I managed to find for LOD and LOI for resources and legislation to be used. So for instance, the BS-EN 19651 is the Organisation and Digitisation of Information on Building Works. This is a standard to be followed within the BIM world, and the second one was the BS-1192 from 2007, which is the creation of collaborative production of architectural and engineering construction information, and this is a code of practice, which means that all industries and aspects of BIM management and drawings will follow this practice to allow sharing of work and multiple groups to be able to use the same model. Thank you all very much for listening. I hope you found this at least semi-interesting and informative, and I'll now lead you on to the next slide. Thank you very much. Goodbye.
My name's Ravi and I'll be taking you through the future research portion of this presentation. So, what are the developments happening in the industry? Well, with improvements to BIM, we'll be seeing potentially BIM level 4 through to 6 in the not so distant future. This could see the likes of 8D BIM, 9D BIM and even 10D. These new dimensions will see integration of different level of information, which could be the health and safety information, could be security, emergency, disaster and even constructive and resource management information. We have level of detail LOD 100 to 500 currently, but we could also see LOD 600 and LOD 700 in the future as well. With all these improvements within the industry, inevitably there's going to be a boost in productivity, as the faster sharing of information will be more efficient, and also lower costs, which will increase the efficiency of the project planning. Also, the advancements in handling data, the more data will be able to be handled, will improve the capabilities of the software and also the user, distributing more output of work and efficient and producing higher quality work as well. So this will also offer smaller projects to be able to be using BIM and have a productive role in the construction processes of smaller projects in smaller markets. Also, the improved clash detection. This process is rapidly improving with the help of IFC files, especially. And the improvements to this can help detect these problems that emerge quicker and that can be revised quickly for quicker processes in construction. Does a better solution exist, and can it be developed further? Well, BIM is the most evolved and effective solution in the industry currently, due to the levels of detail and levels of information that can be provided within the modeling. There's predictions that BIM will make CAD obsolete as it continues to grow. BIM will allow a quicker design process, as the system can draft the building quicker than CAD can. And this is something that we will start to see in the future. Can the tool and software be further expanded? Well, of course. With continuing improvement, even to the effectiveness of the clash detection, that's going to help increase the productivity of the use. Also, to continue to simplify the early stages of BIM will encourage the practices and the people that don't know how to use it comfortably, and therefore they will have training and education and sufficient education on the software for them to develop an expertise in the software. So that's some of the limitations holding it back at the moment. Is obviously the cost. It's very high cost, and for it to be worthwhile, it has to be used at its full capacity, and that's something that I think, due with time and improvement, we'll see a lot more operators becoming more comfortable with the software, and that was another issue, that the lack of expertise on the software. Additionally, it still has legal ramifications. There's legal issues and ramifications of using BIM, so I think that's something that needs to be tackled. And also the incompatibility with partners. Some contractors and partners are unable to use the models, and that's something that, with making it easier in some of the earlier stages, then a lot more people can use it and a lot more people can gain this information and then help develop buildings and processes quicker.